Okay, for this activity, the problem that we posed was Katie has 5 blocks. Her brother took 3 blocks away from her. How many blocks does Katie have left? So what we noticed about the student reasoning would sound something like this. When solving the problem, some students will demonstrate that they understood that Katie took some blocks away. They might do this by crossing out the blocks that were taken away, which this student did. And you can see the black X's through 3 of the blocks here. I noticed that your child had a good understanding of the content of this problem. He represented the blocks that were taken away by crossing them out. I also noticed that he did not write out a numerical answer, so it has me wondering if he understands the concept of numerosity. I am wondering if he could write out a numerical answer given the work he completed on this problem.
We suggest if you notice your child crossing out but not identifying the final amount, I have provided you with an activity to complete with your child and family at home to help build their understanding of numerosity. This will help your child understand that any group of objects has a numerical value that goes with it. By having the child count objects out of a group and adding it to a pile in front of them, it is helping him be able to count the number of objects and state the numerical value of the group. Along with explicitly teaching your child the concept with the activity I provided, another suggestion would be to ask about the numeric value of the groups in your everyday life. If you notice a group of objects, you could ask your child, how many objects are in the group? Then explain to them that this is the numeric value of the group.
So the activity that we have suggested would be good to practice with your child would be this. It's called the toy box. So what you do is you place a collection of small objects in the center of the table, and you have a few people sitting around the table. One person would roll a dice just labeled 1 and 0. If the die displays 1, the child takes 1 object. If the die displays 2, the child does not take anything. You take turns with the child building individual collections. When one child has a few objects in their collection, you ask them how many they have. Encourage the child to touch and count each object, saying each number in turn. Ask how many altogether. Emphasize that the last number in the count corresponds to the number of objects in the collection. Continue to play until one child has 5 objects. And then some things you can do to vary the game would be to vary the size of the objects, the color of the objects. You could also vary the kinds of objects that you have. And then if they get good with doing 0 and 1, you can move it up to 0, 1, and 2.
Why is this a next good step? This is a next good step because it allows the students to provide a numeric answer to groups of different types of objects. Since the original problem, the child did the work correctly but did not write a numeric answer. The student needs to realize that every group of objects has numerosity. By allowing the child to practice this concept with objects in everyday life, he will be more engaged about learning about the concepts. Some responses that we expect are children may count the number of different objects and not every single object in the group. Therefore, they might have the incorrect answer and the incorrect number of objects, but just counted the same types of objects.
And then our response to that, if a child would say that, would be to suggest that the student knows how to count numerical but does not understand that even objects are the same, need to be counted as different objects. To make it more clear, you could have the student point to each object and count aloud.
A second response we might expect is some of the students may be emergent counters. They will count in unorganized sequence such as 1, 2, 4, 6, 7, and so on, and might not know the number word sequence. This will make it hard for all of them to get the correct answer since they cannot coordinate each number with the item.
And then a response that we would say to a student that did this would be that we think the student is still an emergent counter and is not yet able to count perceptually. If the student does not yet know the number sequence, they can still understand that a collection has how manyness, but it will be hard for the child to find the exact amount without knowing the number word sequence.
And the third response we expect is that the students will come up with the correct answer for the problem.
And then the response we might suggest for this would be that the student has mastered or is very close to mastering the intended learning goal, which is establishing the numerosity of a collection. Students usually use perceptual counting to find out how many are in a small collection by pointing and counting all continuously, but if it's added to the previous pile, this child is able to count on.